This is the first step in my MinNazaOSD project. Now what we're going to be doing is hooking an OSD to the Naza M Lite. So in order to do that, we have to prepare the OSD board for that. What we want to do is avoid powering the second stage from these connectors with 12 volts, because that gets the boards kind of hot and has extra current draw. So to do that, we need to pass the 5 volts through from this end to the other end. The top board here is from DIY-Drones3DRobotics.com, and the board at the bottom here is from RC Timer. They have slight differences, but they do the same function. So let's start by looking at the one from RC Timer, which is this one. First thing I had to do was connect the 5 volts to both stages. Now this MinimOSD is really called Mavlink OSD because it came from RC Timer, and that's what they call it. Same thing as a MinimOSD from 3D Robotics. The difference being that the 3D Robotics version has a couple jumpers on the back you can solder to let the 5 volts through to the second stage, so both stages are on 5 volts. These you can only power the second stage on 12 volts and the first stage on 5. So what I did was I cut the edge to the 12 volt pins, and right there I cut the edge. So now the 12 volt pins don't go to the board. They are still connected with each other, so you can pass the 12 volts through from your camera to your transmitter to power both of them, but it won't provide power to the board anymore. We're going to get that from the 5 volt pin over here. So then, as you can see, I ran a wire from the 5 volt pin over to this little choke here on this pin right here. And I got that idea off RC Groups, I believe. And you can apply a little hot melt, or I use a little bit of rubber glue to hold the wire down right here. And I put a little bit of rubber glue over this solder connection to protect it. So here's the 3D Robotics version, and it's called MinimOSD. And you can see on the back here it's DIY-Drones.com, 3DRobotics.com. So this is the other version. Now on this one it's a little simpler to pass the 5 volts through because there's already a couple of jumpers on here that you can solder. Now one of the jumpers is right here, so you just put a solder bead on that jumper, and then on the back there's another one right here, and you solder that one, and then that passes the 5 volts through from this stage to that stage. Let me just turn it around here. So it goes from here over to through to the second stage. Now we still need to cut the edge. We don't have to, but if you don't cut the edge, you got to remember not to plug the 12 volts onto these center pins right here, and that goes for both of them. And another reason you might want to cut the edge is later you might want to put a resistor divider on this 12 volts to ground and run it over to this Atmel chip so that you can display the video voltage, and that's a mod you can do. So that's another reason you might want to cut it. So to cut the edge on this particular model, it's right down in here, and you basically just take an X-Acto blade and just dig in and slowly peel back the edge, and once you get it peeled up, go on the other side and cut it off. And that's about all there is to cutting the edge. So once you've done that, you have completed the first step. So now I can take my 5 volt source, which in my case is a battery pack. Yeah, I know they're usually more like 6 volts when you put 4 of them, but some of my batteries are run down a little bit, so it's closer to 5. And so what I do is just connect this on. It's just a little servo lead. It has 5 volts and ground on it. And now you can see the first stage is working and the second stage is working. And you can see my little data light blinking right here. Okay, let's get the firmware hex file from the wiki. We'll go right here to compile code. Now you can compile the code yourself using this top section, or you can go to the RC Groups forum here and download the firmware hex file. We've got the firmware hex file in a zip file on our computer now. Let's just open it up, go to the GJI folder. I use the no lead version because I'm not going to be using the lead. Okay, now go and get the config tool. Drag the config tool folder to the desktop. Now you can close Windows Explorer, close RC Groups. Let's place the hex file and the config file together, and let's get into the config tool. Now we're going to delete this old OSD file because we don't need those panels that they're using. we're going to put our own in. Okay, let's move the config tool folder onto the desktop. Then we're going to go back into the zip folder right here and drag the MinimOSD file into the config tool folder. And then we're going to delete the zip file and we'll move the hex file in there for the firmware. And everything's in here, the hex file, and we also have our OSD file. Let's launch the config tool. Alright, first thing to do is get the OSD file and load that up into it. Alright, we got that. Now check NTSC, and we're going to connect up the FTDI connector and put our OSD on it on the USB port. It's COM8. Okay, let's upload the firmware. This is the hex file being uploaded to the OSD. Now that's done. Now let's save each tab one at a time. All 3 tabs, just saving it to the OSD. Alright, that's done. Now you can upload the character set if you want to. I didn't do that, but there it is. And we're all done. Now all we need to do is test our OSD and see if it looks right. So I have a 3-cell 12-volt LiPo here, applying voltage to my camera over here, and also it would power my Video TX, which isn't hooked up. I've got it going straight to a monitor. So the 2 plugs are right here for the camera and what would normally go to the transmitter, and 12 volts from the battery is just being passed through from one to the other. It doesn't go to the board. And so let's just connect up the 5 volts going in and see what we get on the screen. Okay, so here's what we got. Now if you look right about there on the screen, you'll see the RSSI. And just watch this while I put my finger on it. See how it drops down? That's because the firmware that we loaded onto this MinimOSD activated the unused ports on this Atmel chip. So now the chip is able to read the data coming in. Now the pins normally float about 5 volts, or they're 5 volts a high. When I put my finger on it, it grounds them. So you can see 5 volts on the input of the pin gives you 100% RSSI, and then ground gives you 0. And the same goes for the voltages, which are over here in this area, or the voltage for the battery. You can also see that changing, and it works in the same way. So it's set up right now in the program for like a 4-cell battery at 5 volts input, and so that's how the whole thing works. It looks like it's working good. So the next step will be hooking it up to the DJI Naza M Lite.